So welcome again to the third tutorial. So in this tutorial, I will be talking about the instruction decode stage. We will talk about the fetch. We'll be talking about the decode stage. So as you can see that once the instruction comes out, it goes to the decode stage. So let's see how this instruction decode unit actually decodes it. Remember that the Verilog code, you can get the Verilog code to this. This is not just a diagram, it's actually a simulated execute. So this is what the instruction decode unit looks like. A lot of things are going on here, but I'll just briefly talk about the key points. So here you see for an input, these are the only inputs to the decode unit here. One, it takes the instruction decode enable. We talked about the decode enable in the last tutorial. It's always on if everything is okay. But if there's an error, the hazard detection unit, this hazard detection unit will turn it off. So and if it's turned off, that means it's not going to be working. So once the instruction decode enable is on and the instruction comes in ready here, turns on this multiplexer in here and it goes into the instruction register. So then you have these two other inputs. These are coming from the register. So when you get to the register, you see how they are also generated. So remember the register, they are registers are addresses too. So I'll show you how you get these register values. So whenever the instruction comes in to this instruction register, let me highlight the signal so you see how it's being broken down. So you can see here is broken down into four equal parts. Okay, they are not equal, sorry, into four parts. These are the Y splitter. One, two, three, four. So among them is this register address. I have register address 1 and register address 2. So these register addresses, they are coming from our 16-bit instruction, which we just broke down into four. This one, when you go to the code, you see the actual bit of the instruction that contains this register address 1 and register address 2 is still part of it. You can see the highlights here, goes here, and then register 1 goes here. So these two, after they are broken down, these two addresses, register 1 and register 2, will go to the register substitute and get the data there. So that data is what you see here. So when we get to the register, you see where this register address comes as an input and this register data are given out as output. So then again, we have another very important bit. Remember our branch which we talked about in the last tutorial. You have this branch offset which is still part of the instruction after the decoding. But for it to work, this branch taking must be selected. If it's not selected, that means this branch will do is a different function altogether. When I highlight it, let me highlight it. You can see it serves as another input here. So what is trying to show is that in a situation where this branch taking is not on, that means this is not going to serve as a branch for the instruction fetch unit, because this branch taking compulsory must be on for the program counter to branch. So if the branch taking is not on, that means it's not going to branch. So it's going to be used as a different thing altogether. I've highlighted it. So which is this? It's going to serve as a second input to the area. So when we get there, you see how it's being used as a second unit. So it's going to choose between here and the second register, the data, which is courtesy of this output. So let me highlight the multiplexer that choose between the register data and the branch data here. I've highlighted it, so you can find it here. This the bit that does the option of selecting. So I'll also show you how this bit is being generated. So I'm just giving a round overview. When you go through the code, all these things will be very easy. So this is it here. This bit here, this is a 4 bit and it's still part of the instruction after it's being decoded. So let me highlight it so you see. It's called instruction code with bubble. You can see where it's part of the instruction is coming from. So once this bit here is on, once the instruction enable, let me highlight it. The multiplexer that does the selecting, I've highlighted it. You can follow it so you see. That's the instruction decode enable. So if the instruction decode enable is on, it's going to come here and select this. Sorry, let me remove. Once the instruction decode enable is on, it's going to choose this part of the instruction. Else is going to be 0. So else is going to be 0. Sorry, I started it. So else is going to be 0. So is this 4 bits here that goes down? Let me highlight it. It goes down here and is used to manipulate these 4 more multiplexers here. Manipulate this one, this one, this one, and this one down here. So let me show you what they do. So one is the write back enable. So the write back enable will be used when we'll be dealing with the write back stage. So these the points where they are being generated. The write back multiplexer, the LEO command. The LEO command choose which command to be operated in the LEO, and then finally this LEO SRC source. So this instruction decode unit generates a lot of signals, including the memory write enable signal, the write back destination, then very important, the bulk this pipeline register out one and out two. So it's called the pipeline register because it has the features of a pipeline that is moving. You are going to see how this pipeline register is moved from one unit to the another. So that's where the name pipeline register out is gotten from. So what it does actually is it packs a lot of signals together, packs them together. Like here, you can see that for this register out one, it has the read register read data one that is coming from the register. Then also it has this LU source 2, then it has this one also. Then the pipeline register 2 has a lot of different, this is 5 different signals all combined together. So the reason of the compression is just so we won't be having them individually, moving them from one unit to another. So all of them were compressed together as a pipeline register. When you go to the code, they are all together one bit is a 57-bit unit. But I just broke them down into 3 individual units. So that's why it gets the name pipeline register. It's going to be it moves a lot of signals together from one unit to another. So when you go through the develop code for this decode unit, you will understand it more. You can email me for the logisim circuit. I will gladly give it to you so you'll be able to understand it more. So please subscribe to my channel and like my video. So this is where it comes to the top. So that is why I told you it has a lot of output that went to different parts of the circuit. But for it to be a pipeline, as we indicated before, The three pipeline register out, you can see them here. Sorry, let me these three pipeline register out. You can see that they went to the execute stage, all of them together to the execute stage. So in the next tutorial, we'll be talking about the execute stage and what happens in it. Please like and subscribe.